Hi, my name is Mike Reed from REDMAK Pop-Up Studio, and in this film I'm going to talk to you about cold bridging. In my third film I talked to you about the placement of a steel frame in the external fabric of the building and suggested that there's an ideal location for it, which is in the inner leaf. And also in that film I suggested that there is an inherent problem with that decision, and that is that at the base of the wall there is a cold bridge problem. So just forgetting the steel frame part of the construction for the moment and reverting to that normal UK construction type, the load bearing cavity wall. Here is a diagram, vertical section at the base of a wall, cavity masonry wall, in this case a raft foundation, and it indicates the cold bridge issue to you. So we've got brick, block, cavity wall, ground out here. Cold is trying to get through that piece of construction and is prevented from doing so a small amount by the block work, a small amount by the brickwork, but mostly by the insulation. And in this case, let's just pretend that that insulation is mineral fibre, a fairly ordinary insulation type, and let's say it's 100mm thick. That line is a direct passage of heat from the inside to the outside, or for cold from the outside to the inside. This is a similar passage and is a line that is not much longer than this one, but bypasses both of our main pieces of insulation. Therefore, this block is causing us a cold bridge. Now there's a fairly simple way of making things a little bit better. If you think about the idea of making the insulations overlap more than they do in that first diagram, then that's our principle. We're trying to make what is an inevitable cold bridge into less of a cold bridge. So with exactly the same build-up, in this case we're going to have the floor level the same height, the ground outside is at the same level, our foundation is deeper, consequently more costly. We're no longer talking about a raft because the strip footing underneath the cavity wall is separated out from whatever construction the slab sits on. So hardcore, blinding, insulation, damp-proof membrane rises up, And the cavity tray directs any moisture out through a weep hole, minimum 150 above ground level. In this case, this coal bridge line or passage is longer than this one. Our coal bridge is now formed by 3 concrete blocks, so we've made things significantly better. However, when your structural engineer is working with you on your project, he or she will want to ensure that this ground doesn't exert so much pressure on the side of that brickwork that it moves into the cavity, which is only filled with insulation. In this case, a rigid closed cell insulation, because it's below DPC level. It's likely that this dimension will be limited to about 450 millimeters. So that means that the length of this arrow is 450, 100, 450, about a meter, whereas the length of this arrow was 200, 300, maybe 400. The thermal resistance of these elements of construction are mineral wool about 0.04 watts meter K, brick and block work 0.8, mass concrete 1.2, and when we come to it, the piece of steel frame 40. What that means is that the brick and block work are about 20 times worse at preventing heat loss than mineral fibre. Mass concrete is 30 times worse, and steel is 1,000 times worse. So looking at a small piece of plan of that wall, but where the steel frame would be, brickwork outer leaf, mineral wool filled cavity, blockwork with a gap in it, steel frame, in this case UC section, universal column, presumably plaster around the inside. So the principle is that piece of steel work is in exactly the same thermal zone as the block work, which means those 3 blocks which are causing a coal bridge are now going to have at intervals a column which would generally be thicker than the blockwork wall. So here it is in elevation beyond. That piece of steel work causes a massive coal bridge. Here's the base plate of the column with its holding down bolts, and locally to the column is a pad foundation, so wider footing than for the masonry cavity wall. So the only solution I have for you to stop coal bridging in steel is to use a structural isolating pad, which is a block of dense plastic, and here it is, rectangular thing with some holes cut in it. Here's a column, here's a beam with an end plate on the beam. And you can see that the bolts bridge that piece of dense plastic. However, the major pieces of steel are isolated from each other. Thank you for watching.